On note 7.2, we're going to be looking at horizontal asymptotes. So the graphs will be approaching a horizontal line. So it says here's the graph of f of x equals x plus 3 over x plus 2. Do you see a horizontal asymptote? So we're looking at these two different graphs here, and look and see if it's approaching a horizontal line. So notice right here, the horizontal line, it's approaching it's crossing the y-axis, and it's crossing it at 1. So that horizontal line would be y equals 1. Okay, so it says if f of x equals n of x over d of x, which just means the numerator, denominator, if they do not have any common factors, f of x has at most one horizontal asymptote. So it's never going to have more than one. It's either going to have one or none. Okay? All right, so it says if the degree, if the degree of the numerator is greater than or less than the degree of the denominator, then your horizontal asymptote would be y equals 0, which is the x-axis. Okay, so then it says if the degree of the numerator is equal to the degree of the denominator, then the line y equals a over b is your horizontal asymptote. A is your coefficient of the highest powered variable of the numerator, and b is your coefficient of the highest powered variable of the denominator. Okay? Alright, and then the next one, it says if the degree of the numerator is greater than the degree of the denominator, then there is not a horizontal asymptote. Okay, so let's talk about degree. Degree is talking about the highest exponent. Okay, so whenever you're looking at finding the degree of your polynomial, you're looking at that highest exponent that your variables have. Okay? Alright, so let's take a look at the back. It says find the horizontal asymptotes of each of the following. So you're looking at the degree. The degree is the highest exponent. Okay, so let's look at the top. So notice we have an x cubed, so that degree would be 3. And then looking at the bottom, the highest exponent is a 2. So 3 is greater than 2. So if you look back over at that front page, if the numerator is greater than the denominator, then there's not a horizontal asymptote. So you would just write none here. Okay, so looking at number 2, if you look, we have an x, that exponent is a 1, and that's the highest one, so 1. Looking at the denominator, we have an x, so that degree would be 1. Those are equal. If the numerator degree is equal to the denominator degree, then your horizontal asymptote is y equals a over b, which just means your leading coefficients. So go over to your rational function. The degree of the coefficient of the x there is a 2, and that's a 1. So it would be y equals 2 over 1, which equals 2. Make sure on your horizontal asymptotes that you're writing y equals. You can't just write 2 there. We have to know that it's a horizontal line. So if they're equal, you're just looking at those leading coefficients and you're dividing them. So it's the ratio of those leading coefficients. Alright, so let's look at example 3. So notice we have an x on top, so that degree would be a 1. Notice the highest exponent in the denominator is a 2. So 1 is less than 2. So if your numerator degree is less than the denominator, your horizontal asymptote is y equals 0, which is the x-axis. Okay, looking at 4. Notice on the top here we don't have a variable. That means the degree is 0 because there's not a variable there. Anything to 0 is just 1, so we don't have a variable there. Degree of the denominator would be a 1. 0 is less than 1. We just went over that on the previous one. If the numerator is less than the degree of the denominator, then it's y equals 0. Okay, so we're going to, on the next part, find the domain, which we talked about on note 7.1. We're going to find the vertical asymptotes, or asymptote, which we talked about on 7.1, and then we're going to find the horizontal asymptote, which is what we did today, if there's one that exists. Okay, so remember on 7.1 that we talked about the domain is of a rational function, which is a fraction, is all real numbers except what causes your denominator to equal 0, because that would be undefined. So we can set that denominator equal to 0, so that x value would be -2. So x cannot equal -2, but any other real number, because it causes your denominator to be 0. Whatever that number is that causes your denominator to be 0 is your vertical asymptote, so it would just be x equals -2. Now we're looking at horizontal. That's what we learned today. So the degree of the top is a 1, degree of the bottom is a 1. Those are equal. So your horizontal is the leading coefficients, the ratio of the leading coefficients. So look in the very front, that's a 1, that's a 1. So when we divide those, y would equal 1. All right, let's look at 6. If you look at the denominator, we're not able to figure out what those x values would be to cause that to be 0. So we need to factor that denominator. So 3 terms, we're wanting to add to 2, multiply to -3. So that would be a +3 and a -1. And we won't need to use the swing method there because that coefficient in front is a 1. Okay? All right, so once we factor that denominator, now we can figure out what domains will not work. So we set each one of those equal to 0 because we don't want the denominator to be 0. So that would be -3 and +1. So your domain cannot equal -3 or +1 because that will make it undefined because the denominator would equal 0. Those values are your vertical asymptotes. So x equals a -3 and x equals 1. Horizontal, that's what we did today. So look at your degree. So the degree of the top, remember it's your highest exponent of your variable, so that's a 1. Degree of the denominator is a 2. 1 is less than 2. Whenever the numerator degree is less than the denominator, it's y equals 0. Okay, so let's look at the back. All right, so we need to factor that denominator in order to figure out what that domain cannot equal. So notice they have an x in common, so you'd be left with x minus 4. So we're setting each one equal to 0, so x would be 0, and x would be 4. So we know our domain cannot equal those two because that would make it undefined. And then that is your vertical asymptotes, so x equals 0, x equals 4. Horizontal, check your degree. So looking at the top, the degree is at 3. Degree of the bottom is a 2. 3 is larger than 2. So if your numerator degree is greater than denominator, you do not have a horizontal asymptote. Okay, the next part we're getting a graph and we're going to identify the horizontal and the vertical asymptotes for each of your rational functions that are graphed. So horizontal, see what the two lines are approaching, which horizontal line. So it's y, it crosses the y at 1, 2, 3. So that would be y equals 3. And then we want to find the vertical one. You're always reading your graph from left to right. So start on the left side and see where that line is approaching. So it crosses the x at -3. Okay, if we look at 9, notice those are both going in opposite directions. So that's what it looks like whenever there's not a horizontal asymptote, because neither of them are approaching the horizontal line. Vertical asymptote, again, read from left to right. So it's approaching it's crossing the x-axis at -1. Okay, so 10, the horizontal, notice they're both approaching at 0, so y equals 0, which is your x-axis. And then reading it from left to right, it's approaching the vertical line. It crosses the x at -3. Okay, so notice on 11 that there's 3 different parts on this one. So if that's the case, I want you to look at the left one and then the right one. So look at this one and look at that one there. They will be approaching the same horizontal line, which is y equals 0. Then, if there's 3 different parts, that means you have 2 different vertical asymptotes. Excuse me. Reading it from left to right, it's approaching that vertical line at x equals -2. And then +2. So x equals -2 or x equals +2. Okay, so that's dealing with a rational function. You have horizontal asymptotes and you have vertical asymptotes.